You press a switch, and instantly, light fills the room. It feels so simple, so routine. But behind that glow is a brilliant combination of electricity and physics. Ever wondered why bulbs glow the moment you switch them on? Let's break it down in simple terms. To start, a bulb glows because of something called an electric circuit. When you flip the switch, you complete the circuit, allowing electric current to flow from the power source to the bulb and back. This current flows through a material inside the bulb, most often a filament made of a special metal like tungsten. Now here's where it gets interesting. As the electric current passes through the filament, it meets resistance. This resistance slows the flow of electrons just enough to generate heat, lots of it. In fact, the tungsten filament can heat up to 2,500 to 3,000 degrees Celsius. At that temperature, the filament becomes so hot that it glows, producing visible light. This process is called incandescence. Think of it like this: rub your hands together quickly. They get warm due to friction. Now imagine tiny particles, electrons, rushing through a narrow path in the filament. The friction they face in the metal generates enough heat to create light. In the case of LED bulbs, the glow happens differently. There's no filament. Instead, electricity passes through a semiconductor, releasing energy in the form of light directly. This is called electroluminescence. It's far more efficient, which is why LEDs don't get very hot and last much longer. Here's a real-life comparison. Incandescent bulbs are like firewood, lots of heat, some light. LEDs are like lasers, focused, efficient, and cool to the touch. The glow of a bulb isn't just about lighting a room, it's a real-life example of how energy changes form. In this case, electrical energy is being converted into heat and light energy. Right pointing finger emoji. If you're finding this everyday science exciting, please take a moment to like this video and subscribe to the channel. There's so much more to learn from the simplest things around us. Now, why is understanding this important? First, it helps you make better choices when buying bulbs. If you know how incandescent, CFL, and LED bulbs work, you can choose the one that suits your needs in terms of brightness, energy savings, and lifespan. Second, it teaches us about electrical safety. For instance, older filament bulbs can get extremely hot and even cause burns or fire if touched or left near flammable objects. LEDs, on the other hand, stay cool and are safer. This knowledge also helps in fields like architecture, electronics, and interior design, where lighting isn't just about brightness but also energy efficiency, aesthetics, and sustainability. In science and education, understanding how bulbs glow introduces students to core physics concepts like resistance, current, circuit design, and energy conversion. In fact, the Hummel bulb has played a huge role in making people curious about electricity since the days of Thomas Edison. Even in modern technology, the principles behind glowing bulbs are used in displays, headlights, signal indicators, and even space equipment, where reliable lighting is crucial. So the next time you flip a switch, remember, you're not just lighting up a room. You're activating a tiny marvel of science, where electric current, heat, and resistance come together to create something we can see. It's everyday magic, powered by pure physics.